Good day everyone, we are the first group and we are the discussants of length and dot product. Before we proceed, let me introduce ourselves. I, Ginny Alonzo, and my partner, Martina Gabriel Alejo. So here are the objectives of today's presentation. So at the end of the discussion, the learners are expected to be able to find the length of a vector and find the unit vector. Next, find the distance between two vector. Third, find a dot product and the angle between two vector, determine orthogonality, and verify the Cauchy-Schwarz inequality, triangle inequality, and the Pythagorean theorem. Lastly, use a matrix product to represent a dot product. So the first topic that we are going to discuss is vector length. So the length of a vector, commonly known as the magnitude, allow us to quantify the property of a given vector. So here is the definition of length of a vector in r raised to n. So the length or norm of a vector v sub 1, v sub 2 going to v sub n in r raised to n is given by the length of a vector is equal to the square root of v sub 1 square plus v sub 2 square going to v sub n square. So, for a better understanding, let's have an example. So, first example, finding the length of a vector. First, we are going to find the length of u. Next is the length of v and the length of u plus v. So, first, let's going to find the length of u. So, here are the given. U is equal to 1, 2, 1. V is equal to 0, 2, negative 2. So, first, we are going to find the length of u. So, using our formula, we are going to substitute the value that we had in u. We have the square root of 1 square plus 2 square plus 1 square. So, simplifying, we have the square root of 1 plus 4 plus 1. So, after that, we got the square root of 6. That is the length of u. Next is, let's find the length of v. So, using again the formula, we have the square root of 0 square plus 2 square plus the negative 2 square. Simplifying, we got the square root of 0 plus 4 plus 4. So, next, we got the square root of 8. So, the square root of 8 is 2 square root of 2. Next, we're going to find the length of u plus v. So, from that, unlike the two length, we just use the formula and substitute the values of u and v. Here, we are going to add the two vectors. And after that, the sum of the two vectors, that is what we are going to substitute to our formula. So, u, we have 1 to 1, and the v is 0 to the negative of 2. Adding those, we got 1 plus 0 is 1, 2 plus 2 is 4, 1 plus the negative of 2 is negative 1. So, using our formula, in getting the length, we got the square root of 1 square plus 4 square plus the negative of 1 square. And simplifying, we got the square root of 1 plus 16 plus 1. And the answer is the square root of 18. So, we are going to reduce it. So, the square root of 18 is 3 square root of 2. And that's our answer for our first problem. Let's have another problem. So, we are going to find the length from P to negative 5, 3, and 8 to Q, 7, 6, negative 2, and negative 3. So, again, just like the first example, we are going to get first, here we are, our clue word is from. So, we are going to use subtraction. So, we have to subtract Q to P. So, here, we have 7, 6, negative 2, negative 3, minus 2, negative 5, 3, and 8. So, 7 minus 2, we have 5. 6 minus the negative 5 is 11. Negative 2 minus 3, negative 5. Negative 3 8 minus 8 is negative 11. So, um, using our formula, we have 5 square plus 11 square plus the negative of 5 square plus negative 11 square. Then next, simplifying, we have the square root of 25 plus 1 to 1 plus 25 plus 1 to 1 is equal to the square root of 292. So reducing, we have 2 square root of 73. So that is the length of PQ. So the next topic is unit vector. A vector V is an element of r raised to n such that the length of x is equal to 1, and that is called the unit vector. So theorem, if V is a non-zero vector in r raised to n, then the vector u is equal to V all over the length of V has length 1 and has the same direction as V. This vector u is called the unit vector in the direction of V. So again, let's have an example for a better understanding. So here we are going to find a unit vector in the direction of u and in the direction opposite of that of u. So given we have u is equal to 3, 2, and negative 5. So first we are going to find the unit vector in the direction of u. So the formula that we are going to use in that is 1 all over the length of u times u. So before using this formula, we are going first to find the length of u. So here, the length of u is equal to the square root of 3 square plus 2 square plus the negative of 5 square. We gain the square root of 9 plus 4 plus 25. And we gain the square root of 38. After that, we are going to use our formula na. So, substituting the value that we gained, we have 1 all over this, the length of u, we got the square root of 38 times u, we have 3, 2, and negative 5. So we are just going to multiply 1 all over 38 to the value of u. So 1 all over the square root of 38 times 3 is equal to 3 all over the square root of 38. Then 1 all over the square root of 38 times 2 is 2 all over the square root of 38. Then the negative of 5 times 1 all over square root of 38, we have the negative of 5 all over the square root of 38. Next, we are going to find the unit vector in the direction opposite that of u. So here, it's very simple. We are just going to multiply the unit vector that we gained in the direction of u to negative 1. So here we have the negative of 1 times the square times the unit vectors in the direction of u. So we have the negative of 1 times 3 all over the square root of 38. We have the negative of 3 all over the square root of 38. Next, negative 1 times 2 all over the square root of 38 is equal to the negative of 2 all over the square root of 38. Next, negative 1 times the negative of 5 all over the square root of 38 and is equal to 5 all over the square root of 38. So let's proceed to our next topic. We have distance between two vectors in r raised to n. So the distance between two vectors, v and w, is the length of the difference vector v minus w. So definition of distance between two vectors. The distance between two vectors u and v in r raised to n is the distance of u and v is equal to the length of u minus v. So let's proceed to our sample problem for a better understanding again. So here, find the distance between u and v. So we have u is equal to 1, 2, 0, and v is negative 1, 4, 1. So first step, we are going to subtract u1 to v1, u2 to v2, and u3 to v3. So, here, we have u minus v, we have 1 minus the negative of 1, 2 minus 4, 0 minus 1. So, the difference of those is 2, the negative of 2, and negative 1. So, we are going to use our formula in getting the length of a vector. We got the square root of 2 square plus the negative of 2 square plus the negative of 1 square. Simplifying, we have 4 plus 4 plus 5. We got the square root of 9, and the square root of 9 is 3. So, 3 is the distance between u and v. Next is the angle between two vectors. The angle between two vectors is the angle between their tails. So, definition of the angle between two vectors in r raised to n. The angle theta between two non-zero vectors in r raised to n is given by cos theta is equal to u times v all over the length of u times the length of v, wherein theta is greater than or equal to 0 but less than or equal to pi. So, proceed to our sample problem. So, our problem, find the angle between the vectors u is equal to 3 and 1, v is equal to negative 2 and 4. So, first, we are going to find the product of u times v. So, we are going to multiply u1 to v1, u2 to v2. So, 3 times the negative of 2 plus 1 times 4. So, we got the negative of 6 plus 4 is negative 2. Next, so our u times v is equal to the negative of 2. Next, we are going to find the length of u and the length of v. So, first, we are going to find the length of u. So, the length of u is equal to the square root of 3 square plus 1 square. We got 9 plus, the square root of 9 plus 1. And the length of u is the square root of 10. Next, we are going to find the length of v. So, the length of v is equal to the square root of the negative 2 square plus 4 square. So, simplifying, we got the square root of 4 plus 16. And the square root of 4 plus 16 is the square root of 20. So, now, we gained all the values that we can use in the formula in getting the angle between two vectors. So, now we are going to proceed to that. So, our formula is u times v all over the length of u times the length of v. So, substituting the values that we gained, we have the u times v is equal to the negative of 2 all over the length of u, which is the square root of 10, and times the length of v, which is the square root of 20. So, equal to cos theta is equal to negative 2 all over the square root of 10 times the square root of 20. So, in radians form, we got 1.713, and in degree form, we have 98.13 degree.
So before we proceed to the topic number 5, by the way, I am Martina Gabriel C. Alejo, that we will discuss the dot product in r raised to n. The definition of dot product in r raised to n is the dot product of u is equals to u1, u2, u3, u4, and so on until to un, and v is equals to v1, v2, v3, v4 until to vn is the scalar quantity of u times v is equals to u1 times v1 plus u2 times v2 and so on until it reached the un or the limit of its given equation. Sample problem of dot product. We need to find the u dot v or u times v, v times v, and absolute value of u squared. For example, u is equals to 3 and 4, v is equals to 2 and negative 3. In A, we need to find the u dot v or u times v is equals to 3 times 2 plus 4 times negative 3. In here, we need to multiply the u1, which is 3, to v1, which is 2, and u2, which is 4, to v2, which is negative 3. We are having the 6 plus negative 12 is equals to negative 6. Next is v times v, or v dot v, is equals to 2 times 2 plus 3 times negative 3 is equals to 4 plus 9 is equals to 13. Next is absolute value of u squared. First, we need to find the value of u, which is 3 times 3 plus 4 times 4 is equals to 9 plus 16, 25 squared is equals to 625. Theorem 5.3. Properties of the dot product. If u, v, and w are vectors in r raised to n, and c is a scalar, then the following properties are true. Number 1. U dot v is equals to v dot u. U dot v plus w is equals to u dot v plus u dot w. C times u dot v is equals to c times u dot v is equals to u dot c times v. Number 4 is v dot v is equals to absolute value of v squared. Number 5 is v dot v greater than or less than 0, and v dot v is equals to 0, if and only if v is equals to 0. Sample problems of the properties of dot product. Finding the dot products, let u is equals to 2 and negative 2, v is equals to 5 and 8, and w is equals to negative 4 and 3. Here's the solution. A, by the definition, you have u times v is equals to 2 times 5 plus negative 2 times 8 is equals to negative 6. Using the result in part A, you have u times v, or u dot v times w is equals to negative 6. W is equals to negative 6 times negative 4 and 3 is equals to 24 and 18. By property 3 of theorem 5.3, you have u dot 2 times v is equals to 2 times u dot v is equals to 2 times negative 6 is equals to negative 12. Next is by the property of 4. By the theorem 5.3, you have absolute value of w squared is equals to w dot w is equals to negative 4 times negative 4 plus 3 times 3 is equals to negative is equals to 25. Letter E, because 2 times w, or 2w is equals to negative 8 and 6, you have v minus 2w is equals to 5 minus negative 8, and 8 negative 6 is equals to 13 and 2. Consequently, u dot v minus 2w is equals to 2 times 13 plus negative 2 times 2 is equals to 26 minus 4 is equals to 22. Using again the properties of the dot product, we have the vectors of u and v in r raised to n such that u dot u is equals to 39 and u dot v is equals to negative 3 and v dot v is equals to 79. Evaluate u plus 2v dot 3u plus v. Using theorem 5.3, we write the dot product as open and close parenthesis u plus 2v dot 3u plus v is equals to u dot 3u plus v plus 2u dot 3u plus v. U dot open and close parenthesis 3u plus u dot v plus 2v dot 3u plus 2v dot v is equals to 3 open and close parenthesis u dot u plus u dot v plus 6 open and close parenthesis v dot u plus 2 open and close parenthesis v dot v is equals again to 3 open and close parenthesis u dot u plus 7 open and close parenthesis u dot v plus 2 open and close parenthesis v dot v is equals to 3 times 39 plus 7 times negative 3 plus 2 times 79 is equals to 254. Topic number 7, we have the Cauchy squares inequality. Theorem 5.4 is the Cauchy squares inequality. If u and v are vectors in R raised to n, then u absolute value of u dot v is less than or equal absolute value of u and absolute value of v, where absolute value of u dot v denotes that absolute value of u dot v. For example, u is equals to 3 and 4, v is equals to 2 and negative 3. First, we need to find the u dot v, and v dot v is equals to 30. U dot u is equals to 25, u dot v is equals to negative 6, and v dot v is equals to 30. Now, absolute value of u dot v is equals to absolute value of negative 6. We know that absolute value of negative and positive are just the same. So it is equal to 6. Absolute value of u and absolute value of v is equals to square root of u dot u and square root of v times v. Is equals to square root of 25 and square root of 13. Or we need to say that 5 square root of 13. So absolute value of u dot v is less than or equal to absolute value of u and absolute value of v, which is 6 is less than or equals to 5 square root of 13. Topic number 8 is angle between two vectors in R raised to n. By its definition, the angle theta between two non-zero vectors in R raised to n is given by cos theta is equals to u dot v is divided by or over absolute value of u and absolute value of v, where 0 is less than or equals to theta and less than or equal to pi. For example, u is equals to 3 and 1, v is equals to negative 2 and 4. By the formula, cosine theta is equals to u dot v divided by or over absolute value of u and absolute value of v is equals to u dot v is equals to negative 2 over square root of 10 and square root of 20 is equals to negative 2 over square root of 200, and that is negative square root of 2 over 10. Next is orthogonal vectors or orthogonal vectors. By its definition, two vectors u and v in R raised to n are orthogonal when u dot v is equals to 0. We have example here, which is u is equals to 0 and 5, v is equals to v1 and v2. So, by its definition, we are having u dot v is equals to 0. U is equals to 0 times v1 plus 5 times v2 is equals to v1 plus 5 v2 is equals to 0. Topic number 10, we have triangle inequality. By theorem 5.5, triangle inequality is if u and v are vectors in R raised to n, then absolute value u plus v is less than or equal to absolute value of u plus absolute value of v. For example, we have u is equals to 4 and 0 and v is equals to 1 and 1. U is equals to 16 and v is equals to 2. By the given formula of absolute value of u plus v is less than or equals to absolute value of u plus absolute value of v. We have absolute value of 16 plus 2 is less than or equals to absolute value of 16 plus 2 is equals to 18 is equals to 18. Topic 11, the Pythagorean theorem. The theorem 5.6 is Pythagorean theorem. If u and v are vectors in R raised to n, then u and v are orthogonal if and only if absolute value of u plus v squared is equals to absolute value of u squared plus v squared. For example, we have u is equals to 1 and negative 1, v is equals to 1 and 1. U is equals to 2, V is equals to 2. By its formula, from the definition, we are having the absolute value of U plus V squared is equals to absolute value of U squared plus V squared. Absolute value of 2 plus 2 squared by substitution, and absolute value of 2 squared plus absolute value of 2 squared is equals to absolute value squared and absolute value of 4 plus absolute value of 4. So here it is unequal or not equal because absolute value of 4 squared is 16 and 4 plus 4 is 8. So 16 is not equal to 8. Topic 12. The dot product and matrix multiplication. By its definition, it is often useful to represent a vector u is equals to u1, u2, and so on until un in r raised to n as an n by n times 1 or n by 1 column matrix. In this notation, the dot product of two vectors is u is equals to, by column, u1, u2 until un, and v is equals to v1, v2 until vn. Can be represented as the matrix product of the transpose of u multiplied by b. So it's either it is formed by row or by column. For example, u dot v is equals to u times v. So as you can see, it is by formation of row, and the v is formation of by column. So it is just the same if you will find the value of its u dot v. For example, we are having u is equals to 3 and 2, v is equals to 1 and 3. U dot v, 3 and 2 multiplied by 1 and 3 is equals to 3 times 1 plus 2 times 3 is equals to 9.
So here are the practice exercises that we prepared to assess the learnings that you gained from our discussion. So in easy round, you are going to find the dot product, then verify the Cauchy-Schwarz inequality, finding the length of a vector, finding a vector. So these are multiple choices. So in average round, you are going to find the angle between two vectors, finding orthogonal vectors, finding angle between two vectors. And in difficult round, you are going to verify the triangle inequality, verify the triangle inequality for the vectors u and v. Next is, given the vector v, find such that has the same direction as and 1/2 its length. Next is verify the Cauchy-Schwarz inequality. And that's all. Thank you for listening.